Hey guys, welcome to Weather Day 11, finding dew point and relative humidity. All right, today is probably one of the bigger days. Quite a bit to go over. Yesterday was an easy one on clouds, so making up for it today. Don't forget your grades for this week. You got your homework and you got your lab. And after today's lesson, you are good to go on that lab. Okay, I'd still hold off on the CAS learning because you still have a little bit more to go. All right, so here we go. How do we measure the amount of moisture in the air? So when we talk about humidity, how do we know? How do we assign numbers to that humidity? How can we measure and see if it's humid versus dry aside from how it feels? All right, and you got a little worksheet that I want you to work on as well today. Okay, do now. The graph below represents how the rate of evaporation is affected by a certain variable. So which variable is most likely represented by X? What's going to make something evaporate less as it increases? So as it gets hotter, for number one, it usually increases the rate. If it gets windier, it increases the rate. If you have more surface area, it increases the rate. 4, there's your answer. If it's already really humid out and the water in the air is already saturated quite a bit with water, then it's not going to evaporate as much, okay? Next one, 2 identical towels are hanging on a clothesline in a sunny location. One towel is wet and the other is dry. What is one reason that the wet towel feels cooler? Why does something that is wet feel colder than something that is dry? I like this question. It's going to be used today. And also, you should have went over it in living environment. Why do we even sweat? All right, sweat, when the sweat evaporates off of your skin, it removes heat and cools you down. All right, evaporation is a cooling process. All right, so there you go. Okay, so let's get into our notes. Listen, all of the stuff that we do today is going to be going right here on this page, even the practice questions that we do. All right, so you're going to go filling that in as we go, and then this is the worksheet that I want you to complete after for homework. Okay, so we're taking the notes now. So the Sling psychrometer is how that is said. So we've gone over thermometers, we've gone over anemometers, wind vanes, barometers. Now we are on Sling psychrometer, and this is the instrument that we use to find dew point and relative humidity. Okay, it measures the amount of moisture in the air. And essentially, it's this tool that you spin, and it's got 2 thermometers on it. One thermometer is dry, and one will be wet. Okay, and that's going to be the thermometer basically wrapped in like a wet sock. And one thing that I want you to know that's really, 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 really important is that the wet bulb is always, always going to be colder than the dry bulb. Okay? Wet bulb is always colder than the dry bulb because of evaporation. All right? It's a cooling process like we just mentioned below. All right, so here is a picture of a Sling psychrometer. Okay? You basically have this tool that you can spin 2 thermometers at the same time. One is going to be regular and kept dry, and then the other one will be wrapped in this wet sock, all right, that you would dip in water. And as you spin this, it's going to get some temperatures. And notice this versus this. This one is 15 and this one is 20. The wet bulb is always colder. All right, take a look. This guy's going to talk a little bit about it.
So today I want to show you how to use a Sling psychrometer and how to determine relative humidity and dew point. So Sling psychrometer is an instrument that meteorologists use. There are basically 2 thermometers. One's called the dry bulb One's called the wet bulb. You notice that there's a sock at the end of the wet bulb thermometer. We want to figure out how much moisture is in the atmosphere and how much evaporation is going to take place. Okay, you can see that both thermometers are about 25 degrees Celsius. What I'm going to do for the wet bulb, I'm going to take a beaker of water. I'm going to submerge the sock into the water. Okay, now evaporation is going to be a cooling process here. So I want to see how much evaporation is going to take place within this air mass today. So now I'm just going to take the two of these, I'm going to spin them around. Now the spinning increases the wind. Wind ultimately will cause evaporation to happen at a faster rate. The faster evaporation, the more cooling on the wet bulb. Okay, so after spinning for about 5 minutes, okay, our dry bulb and our wet bulb, okay, clearly see, this is my wet bulb here, has dropped down to about 18 degrees Celsius, while my dry bulb is still at about 25 degrees Celsius. Okay, what you're going to do,
All right, that's where we're going to stop. Okay, so you could see, you spin it, wet bulb is always colder than the dry bulb. Okay, so in your reference tables, page 12, you have these two diagrams. You have one that is dew point and one that is relative humidity. Make sure that you pay attention to your question and read the correct chart. Okay, notice over here, they're essentially the same thing, just different numbers in the middle. Dry bulb is your regular air temperature, okay, for both. And then these numbers are the difference between your wet bulb and your dry bulb, okay? And then you just match them up, okay? So let's go through a couple practice examples here. All right, so right here, here's your Sling psychrometer. We said 15 and 20. So that means that our dry bulb is 20. That's the air temperature, right? This is the first example on your worksheet, okay? That means that our difference is 5, okay? So now take a look. This is how you read it. And notice we're finding dew point here, okay? So I'm reading the dew point chart. So we're going to take the difference of 5 and the dry bulb of 20 and see where they meet. And 12 is our answer. So that means that the dew point is 12. Now, follow-up question, is it going to rain? Well, remember what we said about dew point. Rain and condensation only happens when the dew point is equal or close to the air temperature. And here, that is not the case. All right, the dew point is 12, the air temperature is 20, which are not equal, not a lot of humidity, clear skies, not gonna rain. Okay, so now we're on dew point number 2. The dry bulb is 2 and the wet bulb is 2. So subtract, our difference is 0. So now use your chart. Look at where we meet. 2. So our dew point temperature is 2. So now look, dew point is 2, dry bulb is 2. They are equal, so that means we will have rain. Okay, when the dew point temperature is equal to the air temperature, which is the dry bulb, don't forget, then you have condensation and rain. Here's number 3. So now we're working backwards here, okay? So I'm starting off by telling you the difference is 10 and the dew point is 6. All right, so watch. Difference is 10, go down, and the dew point is 6. So now using this information, we can find the dry bulb, which is 24, right? That's easy. Now, how do you find the wet bulb from there? Well, remember what we said. The wet bulb is always going to be less than the dry bulb. So if we have this information, then we could do that. 24 minus 10 is 14, okay? No rain, because the dew point is not equal to the dry bulb. All right, next one. Dry bulb is 15 and the difference is 3. Let's do it. 15. Notice it's in between. Sometimes you get numbers that fall in between. Here's a 14 and a 16. So we're kind of riding that line. And the difference is 3. So our answer is right here in between 9 and 11. So that means 10. Okay? So sometimes you can get questions that fall in between like that. Okay. Is that going to rain? No. Not equal. All right, so now we're moving on to the relative humidity section. Listen, it's done the exact same way, all right? For relative humidity, it's going to rain if relative humidity equals 100%. Remember, that means that the air is fully saturated. So let's do it the same exact way. The dry bulb, which again is the air temperature, is 20. And the wet bulb is 15, so that means our difference is 5. So let's see where they meet. The relative humidity is 58. That is not 100% saturated. That means that it's not that humid out. That means that you will not have rain. Okay? Next example. Dry bulb is 10, wet bulb is 10. So the difference is 0. So now look, if you have them being the same, look at what column you end up with. You have a relative humidity of 100. When the relative humidity is 100, that means that the air is saturated and you will have rain. Okay? Last one. The difference is 8 and the relative humidity is 47. So this is one of those questions where we're working backwards. So the difference is 8. Go down till you hit 47. You could find the dry bulb, which is 28. Finding the wet bulb, you subtract, right? If you have the difference and the dry bulb, you just subtract to get 20. All right. Couple more practice problems down here. So now we're on the bottom section of your note sheet. How does the difference between dry bulb and wet bulb determine humidity? So take a look. Remember what we said. They have to be equal. If the closer the dry bulb and the wet bulb are together, the more likely you are to have rain. So here the difference is 28 in your first example. They are definitely not equal, so you are not going to have rain. It's going to be very dry. Next one, 20 and 18, they're pretty close, so that means it's pretty humid. So you may have rain, but probably not likely. It's going to be humid though. And then the last one, the dry bulb and the wet bulb are equal. Difference of 0, you're definitely going to have your rain. Okay? So in our summary, what is the approximate dew point temperature if the dry bulb is 12 and the wet bulb is 8? Listen, you guys know dry bulb, wet bulb, right? Finding the difference, all that stuff. Just make sure you read your questions right. They're asking you for dew point, so make sure you read the dew point chart. Okay? And if you do that, you should get about 4 degrees Celsius. Number 2, base your answers on the 2 thermometers that show the dry bulb and the wet bulb temperatures of the air. What is the approximate dew point? All right, and if you look over to the right, here's your numbers right here and right here. Okay, so these are going up by 1. So 10, 11, 12, 13, and 10. So 7.5 degrees Celsius should have been your answer. Number 3, a Sling psychrometer shows a dry bulb of 14 and a wet bulb of 9. What are the dew point and relative humidity? Again, it's same type of questions we've been doing this entire lesson. Just make sure that you read the proper charts for the proper questions. All right, and if you do that, you should end up with 4 and 50%. All right, so your job... So we just did all this, right? Your job is to complete this worksheet, okay? And 2 days ago on lesson 9, humidity, we went over this right here, okay? So it's talking about a parcel of air. It's just a chunk of air. So notice in all 3 of these examples, there is the same amount of water vapor, but the chunk of air that it's in, here, I'll do this. Wow, that's not what I wanted to do. There we go. The chunk of air changes because of the temperature. As it gets hotter, the air expands and gets bigger. Okay, so even though it has the same amount of water, relative to the amount of air, the relative humidity will be different. Okay, so just pay attention to those types of questions and understand that parcel of air just means the chunk, the size of the air. Okay? All right, guys, that's it. Please get that worksheet done. Again, I'll post all the answer keys so you could check that out later on, but try to do it yourself first. All right, have a good one, and good luck on the lab tomorrow. Everything we did today is what you can use for the lab.